how to do composites. And let's say, since I'm talking about composites, and you saw one worked out earlier, we start out with maybe, given this time, these two functions. Let's call it f of x. And guys, in this case, I got one very simple one. It's this. And I'm going to use g of x, two functions, will be this. Those will be given to you. You don't have to find them, they will be given to you. Then all of a sudden the question comes up, find, yes, the composite, little circle there, with respect to x, and we'll do it. Now though, to extend this, they may ask you, yes, go ahead and find the composite, but it may be turned around in this order with respect to x. There was a g first. That can make a difference. Or they may ask, for those same two functions, no, find maybe f with f, form the composite that way. And the last one, they could, for a reason, ask you to find this. G with G. And guys, all those are known as composite functions. Everything's got a function attached to it. Not hard, no sketching, my goodness, you don't have to worry about vertical asymptotes and horizontal asymptotes on this. It's just sort of straightforward. Definition though, critical. You saw me do this for the break. This means take f of g of x. That's what it means. G of x in this case is this. I'll put that in blue here. X subtract 5 over 2, thank goodness was given to me. They're asking to find f of that. To finish it up. Which says go back to your f function, thank goodness they gave it to me. Go back to your f function and replace this x up here, I see only one x, by the blue. So you've got 2 times. If you do that and put the blue in there, you have this. Like a substitution. Therefore it's plus 5. That's what my f function looks like when I replace x by x subtract 5 over 2. And then clean it up algebraically. If I cleaned up, the 2's will cancel. That's nice. That leaves me x subtract 5 plus 5. That even cleans up nicer because the 5's cancel, and I can't believe the answer's x. Which can happen. The answer came out to be fairly easy. Just x. Now, let's jump in, try number 2. Number 2 says now try it in this order. This means, guys, g of f of x. That's its definition. F of x was given to me as, I'll put that in black, that's 2x plus 5. That was given to me. And they're asking you to take g of that. After you do a little practice with this, this is not hard at all. Take g of 2x plus 5. Guys, go back to my g function right here. Here's my g function. And put that 2x plus 5 in there. Let me use a different color so you can follow me. Let's put this in green. 2x plus 5. Go to my g function, put that in right here for the x. So we're at 2x plus 5. Put that in parentheses. That goes into the g function. Subtract 5 all over 2. And it looks like that. Clean this up, 5's canceled. I got 2x over 2. Oh, 2's canceled. Are you kidding? I got x again. I wish all functions would work out like this. They don't. I'm showing you something special that's going to happen in this chapter 4 here. Maybe I'll get x again here. I don't know yet. This one means, be careful, this means f of itself. That's the definition. Strange, but that's what it says. Take f into f. F again was given to me as 2x plus 5, and put that in black here. and you're taking f of that. And what does that mean? Go back to your f function right here. Now this one's not going to give you an x. A little bit more complicated. Go back to my f function. Guys, let me do this so you can follow. I hope the colors here. Let me use blue again. Let's say this is in blue. And that means go to your f function and put that in. Well, I guess if I go to the f function, the black function up there, and put that in, that's 2 times 2x plus 5 put in. That's what it means to do, plus 5 on the end. Is that true, guys? Then you clean that up. And I see right now this is not going to be an x here, but this is going to be 4x plus 10 plus 5. Looks like it's 4x plus 15. Final answer. Don't make anything hard on this. But I think some of my students may realize here shortly, they may realize why these two came out to be x. There's something special when they come out to be an x. Over here though, I doubt this is an x, but we're going to do it. G of x. That means, let's go through it and put this in a different color quickly. G of x was x subtract 5 over 2. That is blue. And of course you got G of that. And it looks like that. Now before I finish this up, I guarantee you, I would hope every student would prefer to do this than a graph with a vertical asymptote and find a crossover point. I would, as a student, I'd prefer to do this, chapter 4, professor, than that what we were doing back in chapter 3. Okay, if I try to finish this up, it says go to my G function, which is right here, and put that in. And I've got to be careful when I put it in. That means x subtract 5, that's the blue, and not mess it up here. Well, it looks a little strange. Over 2, back here, and subtract 5, all over 2. Guys, see if I put that in correctly. G of x subtract 5 over 2, go back to the G function here, and replace this x, substitute it with the blue. And leave everything else the way it is. Did I do that correctly? Clean this up, a little bit more work here. Use a common denominator of 2. And guys, let's do this quickly. If I multiply this by 2, common denominator. I think I got x subtract 5 subtract 10. Is that x subtract 15? Over my common denominator, all over 2. Is it, guys? Don't make a mistake. Now, what I finally end up with, here we go, this for a final answer. Is this equivalent to that? And that's my composite of the two. So I did all 4 ways. Now here's a little introduction. Watch my time here. Why, Professor, did in this case, these two came out to be such a simple answer, x, for their composites. And these two were a little bit more complicated. But why were those first two, I wonder, Professor, is there something special about them? The 2 functions that would give you a composite of x? And I would know that ahead of time, Professor, if I saw something like that before I did it. Why did an x? Does anyone have an idea? It's coming up in chapter 4 later. Is there anything special about these 2 functions? Oh, I see a hand going up. Yes?
Are they inverses?
Oh, look at that. He's telling me, Professor, I think you're going to finally identify functions like these 2 as inverse functions. They're inverses of one another. I have not discussed inverses. They're inverses of one another. He's telling me this function and this function are inverses. I don't know whether right now whether my students could look at this and say, Professor, I meet you in the hallway. And I say, well, what's the inverse of 2x plus 5? And Alexander's going to say, Professor, no problem. The inverse of 2x plus 5 is x subtract 5 over 2. Or I meet you in the hallway and I say, here's my function, x subtract 5 over 2, find its inverse. You quickly say in the hallway as we talk to each other, the inverse is 2x plus 5. They're inverses of one another. Now what on earth is making that happen? Now the little time I have for the quiz takes place. I want to do something with you just to get you an idea of what's going on. Real quickly, just real quickly, with your help. I'm going to list 3 ordered pairs that would satisfy 2x plus 5. Just randomly. Replace x by any number you wish. We'll try a few numbers here. I think I'll try 3. That's just a random. Replace those numbers in here. And guys, if I replace a -1, help me out. 2 times -1 is what? -2 plus 5 is what? 3? And that's belonging to that function. Put a 0 in the same function, get a 5. That belongs. Put a 3 in there, I get 6 plus 5 is 11. True? Oh, I love teaching. Love teaching. Now, let's go down to the next function, g of x. Now suppose I tell you now down here in the red, I'm going to list 3 down here for it. And I'm going to choose the numbers for you. To put into the g function. If I put a 3 in there, guys, please help me out. What will you get? 3 subtract 5 is what? -2? And -2 divided by 2 is? Five in there. 5 subtract 5 gives me what? 0? 0 divided by 2 is 0. Something's happening. Put a 11 in there. 11 subtract 5 is what? 6? 6 divided by 2 is 3. Now, tell me what right now the word inverse, in your mind, based on what you saw with those ordered pairs, what would you say, just in your own words, what is it? Opposite. Well, I don't like the word opposite, because if you say opposite, you may think change the sign to a negative.
Switch the x and y.
Tell me again.
Switch the x and y.
The x and y are being interchanged. From one function to the other, the x and y are being turned around. So whatever the x was here, Ignacio, or the x here became the y here. The y in this one became the x here. They have interchanged, and that's the basis of an inverse. But when will you know that's happening? To begin with, without testing points. How many points are there in the universe to test? Infinite. I've tested only 3. I've seen some of these in math where it works for the first 15 and all of a sudden number 16 doesn't work. Thank goodness this one does work. Guys, how's it look right now? Just inverses, interchanging functions. And a few little composites. I think we're finished. I think I got a good start on chapter 4. Now, let's have everything put away. I'm going to walk around and make sure you do have everything put away.